Okay, today we're going to be looking at a new function in our cosmic catalog called the reciprocal function. You'll see why it's called the reciprocal function. Instead of being y equals x, it's y equals 1 over x, the reciprocal of x. And we're going to eventually look at some transformations of this equation. And the transformations are going to look like this. Y equals a over x plus h plus k. And our transformations will follow the same transformations we've been using for all of our functions. The reciprocal function is a little different than all the other functions we've looked at. It comes with some things called horizontal asymptotes and vertical asymptotes. Asymptotes are imaginary lines that the graph can never cross. And the reason this function has asymptotes and is different than the other functions we've looked at in the past is we have x in the denominator. And we know that the denominator can never equal 0. So if x, that means x can never equal 0, which means we have a restriction on our domain. In addition, y will never equal 0 because a fraction is 0 when the numerator is 0. And in this case, the numerator is never 0, it's 1. So what happens is that I have a restriction on our domain and we have a restriction on our range. X can never equal 0, which means this graph can never cross the y-axis. So I'm going to draw a dotted line to show that this graph can never cross the y-axis. This graph can never cross the x-axis either. The line x equals 0 acts as a vertical asymptote. So I abbreviated VA. The line y equals 0 acts as a horizontal asymptote. Those are two lines that the graph can never cross. So if we do a quick table of points here to see what this graph looks like, and when I mean quick, I mean really quick. I can't put 0 in for x, so I'm going to put something either side of 0. I'm going to put -1 and 1. So if I put -1 in for x, I have 1 over -1, which is -1. And if I put in 1 for x, I have 1 over 1, which is 1. So it means this graph crosses through the point 1, 1 and -1, -1. And the shape of the graph looks like this. The graph continually gets ever so close. I'll do this in a different color so you can see it. Gets ever so close to this asymptote, hits this point, and gets ever so close here. And it does the same thing over here. And all of these graphs will resemble this shape, okay? The reason why it continually gets so close to the asymptote is that I'm going to put in a couple more points over here. I'll do another table of points over here. If I start putting in fractions for x, like 1/2, y becomes 1 over 1/2, which is 2. So I have the point 1/2, 2. 1/2, 2 would be about right here. Make it kind of big so you can see it. And then if I put in, say, even something smaller, 1/10, it becomes 10. So the graph shoots way up at 1/10. I'm way up at 1, 2, 3, 4, 5, 6, 7, like right here. So see how the graph is getting ever so close to that asymptote? Conversely, if I put in bigger numbers, say like 10, I get 1/10. So I would have the point 10 on the x-axis, 1, 2, 3, and then it would go up 1/10. So you could see at the point 100, it would be 1/100th. So that's why it approaches those asymptotes. Okay, so now we're going to look at some of the characteristics of this graph. Remember, we have a restriction on our domain. X can never equal 0, and we have a restriction on our range. Y can never equal 0. Okay, I've just sort of uploaded the characteristics next to the graph right here because I don't have very much room. So I don't know why this popped up. So we can ignore this right here. So the domain of this graph, remember, we have to restrict 0. 0 is not part of the function because if I plug in 0 for x, it makes my function undefined. So the domain would be -infinity to 0, union 0 to infinity. That's how you restrict 0 from the domain. We also have to restrict 0 from the range. So the range is -infinity to 0, union with 0 to infinity. Okay. Let's talk about this graph. Is this graph ever increasing? Or is it always decreasing? I'm going to use a highlighter here. And I'm going to trace the graph from left to right. Can you see how here the graph is always going down? And when I jump to the other side of the asymptote, the graph is always going down. This graph is always decreasing. But we can't say it's always decreasing because when x equals 0, it's not decreasing. The graph doesn't exist. So when a graph is always decreasing, we say it's decreasing on its domain. So it's decreasing. This graph is never increasing. It's decreasing from -infinity to 0, union 0 to infinity. Okay, and here's where these asymptotes come in. I have a horizontal asymptote. The horizontal asymptote, and again, I'll kind of go over it a little darker. The horizontal asymptote is this line y equals 0. Okay, so the horizontal asymptote is the line it can't cross. The graph cannot cross the line y equals 0. It also has a vertical asymptote. A vertical asymptote is the y-axis. I'll go over it a little darker. Okay, so that's the line that it cannot cross. The vertical asymptote is x equals 0. Because my x and y axes are asymptotes, I don't have any x and y intercepts. It's not crossing either of those because it's an asymptote and we can never cross the asymptotes. So there is no x-intercept and no y-intercept. And in addition, there's no min and no max because on one side the graph goes up forever and on the other side it goes down forever, so there's no min and no max. Now keep in mind the shapes of the graphs that we're going to look at will always look very similar to this. What's going to happen is we're just going to shift it left, right, up, down. A left and right shift will take the vertical asymptote with it. An up and down shift will take the horizontal asymptote with it. Okay, and we'll also look at what happens when we stretch it. So now you should be looking at the back side of your Cosmic Catalog page, and we're going to be looking at two transformations of the reciprocal function. So the function name is called reciprocal. And the first function we're going to be looking at is y equals 1 over x plus 4. So I added a 4 to the x. We know this from all of our transformations that when you add or subtract a number to the x, it shifts it left or right. In this case, it shifts the graph left 4 units. Okay, now remember, a left-right shift will take the vertical asymptote with it. So your vertical asymptote that used to be at x equals 0, the y-axis, is now at x equals -4. So this is really small. I'll try to see this. 1, 2, 3, 4. It's at x equals -4. So I'm actually going to put that down here. My vertical asymptote is now at x equals -4. Okay. An up-down shift does not affect a horizontal line. A left-right shift. I'll take that back. A left-right shift does not affect a horizontal line. Picture a horizontal line and moving it left or right. It's the same line because it extends forever left and right. So my horizontal asymptote stays at y equals 0. So I'm going to come down here and put my horizontal asymptote at y equals 0. And then all I'm going to do is pick a point either side of my vertical asymptote to determine what my graph looks like. So I'm going to do a little XY table. I'm going to pick a point either side of -4. So I'm going to pick -5 and -3. So if I put in -5 into the function, I have 1 over -5 plus 4, so I get -1. If I plug -3 into the function, I have 1 over 1, which is 1. So I have the point -5, -1, and I have the point -3, 1. And the graph will always follow this shape. Whoops, missed my point a little bit there. So now let's talk about the domain. Your vertical asymptote will always be restricted from your domain. X can never equal -4. That's why it can't cross the line x equals -4. X can never equal -4 because it makes my denominator 0. So my domain is -infinity to -4 union -4 to infinity. You restrict your horizontal asymptote from your range because y can never equal 0. So it's -infinity to 0 union 0 to infinity. The graph is still never increasing. It's always decreasing. And it's decreasing on its domain. If a graph is always decreasing, we say it's decreasing on its domain. So it's decreasing from -infinity to -4 union -4 to infinity. You can't say it's decreasing from -infinity to from -infinity to infinity, because at -4 the graph doesn't exist. So if you're saying it's decreasing from -infinity to infinity, you're saying it's decreasing at -4, and that's not true. It doesn't exist at -4. Okay, so this time I still don't have an x-intercept, okay, because my x-axis is an asymptote. But I do have a y-intercept. And the y-intercept occurs when x is 0. Because you can see now my graph crosses the y-axis. So if I plug in 0 for x, I get 1/4. So this time I do have a y-intercept of 0, 1/4. I do not have a min or a max. I do not have an inflection point, and I do not have a vertex. Okay, let's take a look at another one that may have some different characteristics to it. It's still the reciprocal function. And we're going to graph this one. We're going to throw a negative on there. So -1 over x plus 1 plus 3. Okay, so if I look at this graph, the +1 makes my graph go left 1. The +3 makes it go up 3. And the -1 reflects over the x-axis. So a left-right shift will take the vertical asymptote with it. So the vertical asymptote is now at x equals -1. An up-down shift will take the horizontal asymptote with it. So the horizontal asymptote now is at y equals 3. So this is very small for me to see. 1, 2, about here. So I have a horizontal asymptote at y equals 3. I have a vertical asymptote at x equals -1. Okay, now to see what this graph does, this part will take into account your reflection. If you just take a simple table of points and pick a point either side of your vertical asymptote. So I'm going to plug in 0 and -2, either side of x equals -1. So if I plug in 0, I get -1 over 1, which is -1, plus 3 is 2. And if I plug in -2, I get 4. So I have the point -2, 4, which is right here. So I know that now my graph is up here. I can't cross those asymptotes. They approach the asymptotes. And 0, 2, which is right, whoops. It's hard to see, is about right there. And I approach the asymptote. I touch the asymptote, but you're not supposed to touch the asymptote. Just approaches the asymptote. Okay, so let's talk about the domain. You have to restrict your vertical asymptote from the domain. I have to restrict -1 from my domain because it makes my denominator 0 and it makes my function undefined. So my domain is -∞ to -1 union -1 to infinity. You have to restrict your horizontal asymptote from your range because y is never going to equal 3 because it's never going to cross the line y equals 3. So -∞ to 3 union 3 to infinity. But look at what happened when we reflected it over. Is this graph increasing or is it decreasing? So if I follow the graph from left to right, it's going up here. And from left to right, it's going up there. So this graph now, since I reflected it over the x-axis, is always increasing, which means it's increasing on its domain. So it's increasing from -∞ to -1, union -1 to infinity. And this graph is never decreasing. But this one's even different yet. I have x and y-intercepts. I cross both axes, okay? So we actually already know our y-intercept. It's right here. When x was 0, y was 2. So the y-intercept. So the y-intercept is 0, 2. The x-intercept, we have to put in 0 for y. So that's going to take a little bit of work. So I'm going to do this in a little darker color because I'm going to go over here. So I'm going to put 0 in for the y, and I have -1 over x plus 1 plus 3. So let's look at how to solve this to find out what x is when y is 0. The first thing you're going to do is subtract -3 from both sides. Or subtract 3 from both sides. And then what I like to do in these instances is put the -3 over 1 and use something from geometry called cross multiplication. This times this is -1, and this times this is -3 times x plus 1. And then you have a pretty simple equation to solve. You can divide both sides by -3, or you can distribute the -3. So let's go ahead and distribute the -3. So it's -3x minus 3. Add the 3 to the other side. So I get -3x equals 2. And divide both sides by -3, I get -2/3. So you can kind of see that, by my graph that it crosses the x-axis at negative 2/3. So it's negative 2/3, comma 0. Again, I have no min or max, no inflection point, and no vertex. So the thing to remember is the asymptotes, the vertical asymptote moves with a left-right shift. The horizontal asymptote moves with an up-down shift. Then all you have to do is make a quick table of points, picking a point either side of your vertical asymptote. When you do that, that's going to take into account your reflection and any stretch or compress. Okay, so graphing steps. Graph your asymptotes, graph your horizontal asymptote, your vertical asymptote, and make a quick table of points, picking a point either side of your vertical asymptote.